All right, everyone. We had some technical difficulties, but we are going to have to do with that. Today, we're doing something a little bit different. The environment we're going to work with is not a Jupyter notebook. What we are going to do is to learn how we can use Python to create interactive app for interactive data science, interactive machine learning, things where you can, for example, build a model using on the fly, visualize data on the fly, an interactive dashboard with data visualization and parameter setting that update based on what you want to do. Okay, so that's the goal. That's why before we start, I'm gonna show you one version of what we might be able to create, and then we're gonna do as much as we can, and then I'll give you the code. But essentially, we will be able to basically load the business data set. This is the exact same data set y'all used last week. So we're gonna just do the same thing. And we're gonna be able to do feature selection, run different modeling algorithms, different clustering algorithms, visualize the data on an interactive map, change the number of clusters on the fly, and then get the results, change the algorithm on the fly, and see how things work. Okay? There we go. So you can do all of that. And then you can also have different tabs, run different dimensionality reduction algorithms and see the results. And do some sort of data profiling, take the averages of everything. This is all done in Python. There are several libraries that can allow you to do this. We're going to use the one that I like called Streamlit. The setup that y'all need to have is these. I think you guys have. There is. Let me just. For some reason, my TV just turned on. I think there's some craziness in my house. If I were superstitious, I would have thought that there's some jinns or something in my house because the TV turned on and start playing World Cup. So I'm a bit distracted right now. Okay. So yeah, I can give you the requirements.txt. Just install them. You have pandas, NumPy, scikit-learn, install Plotly, and install Streamlit. I want you to just set up, get setting up environments in a normal way as well. So yeah, start with doing that. And for people who did not have the chance to do it, I can send the requirements, but try installing them. So yeah, let's get that going. Let us know if you have any questions. I'll send them. I'll try to just go to Streamlit. And if you go to docs, installation, you'll see that Streamlit is installed pretty simply. We have a lab task. You'll submit the finalized version of this app.py. No quiz today. Anyone has problems? Anyone has problems with installing? Okay. If not, create an app.py. Will we submit the lab test by tomorrow? I try to keep up with these, but sometimes, yes, we're going to give you enough time. I don't care. We're going to give you enough time for these, for sure. Yes. Yeah, no problem. So just to see how this works, type these, import. Yes. Import Streamlit as st, and then you can simply create a title. Let's say business location explorer, and then you can create st right can just write this, hello, what's happening? Okay, write this. Everything is basically these function calls within. This is very, in my opinion, a very intuitive Pythonic way of creating interactive stuff. It's really simple. When you do this, all you need to do is to type. I'm going to type it here for you. Streamlit in your terminal in the folder that you've installed with the Python setup. You all have been using this, right? Streamlit run app.py. That is the command you will use. I'm going to send it on Discord to start the app. So I'm going to run it. And you should be seeing this. So we good? We are seeing this. Thumbs up, heart, emojis. Type something. Let's see. Not working yet. How's it? Okay. So what's, yeah, it seems like a lot of us not having it working. So that's a common problem. Have you, so if you say, let's say, if you say pip install, you have to see what Python you're using. Mehdi, have you been using virtual environments up till this point for the other things?
Yeah, I actually wrote the same thing in the comment section. If you are using a virtual environment, you have to install the library within that environment, not globally on your system.
So you guys have been doing this.
And if you're using Colab, which I doubt you will be using Colab for this.
Yeah, you're not going to use Colab.
Yeah, you're not going to use this for this because you cannot. Yeah, so if you're on VS Code, you have to first check if you're using the virtual environment. If you're on a virtual environment, you have to install the library within that virtual environment. And I'm going to send the comments on the comment section.
So how have you guys been installing other libraries till now? Within GTA Notebook. So Tim says in a virtual environment, how does a notebook handle that for you? There's like an install something. Oh, that's because you use Colab, right? So if you're using a VS Code with a Python kernel, which is your global Python, if you type Streamlit, then you can do that. And Mehdi, they have to have that virtual environment created first, right?
Yeah, I was assuming that if they are working with VS Code directly, they are using a virtual environment. That was an assumption, yeah.
Okay. Yeah, virtual environment isn't created. So I guess let me.
I can quickly show how they can do it.
We can show it together. Or if you want, they can, because I'm streaming my browser, I
can start streaming if you want me.
Okay, yeah, because you do that.
Yeah, I'm gonna do it. Okay. Okay, can you see my screen? Yeah, you can see my screen. Okay. If you have a terminal, okay, if you're using a Mac, same thing applies to Windows systems. On VS Code, you can have the terminal here. You can open it from the options bar here, new terminal, and make sure that you are in the folder where your Jupyter notebook is. If you want to create a virtual environment, you just say Python-m then. Okay, I already have this here. Okay, so a folder is created here. If you want to activate this, you just can say source when activate. So when this is shown here, it means that your virtual environment is activated, and whatever library you're going to install
-r, yeah.
Yeah, pip install. What was the package name?
Just do -r requirements.txt. Oh, you don't have the same Streamlit. They have,
Streamlit.
yeah.
Yeah, whatever you just run here, it's gonna be installed. And then what you need to do is that when you are here in your Jupyter, on your Jupyter notebook, you have this option here that says select kernel. You select kernel, and then you can choose Python environments. And here you have some suggestions. You probably see the Python installations on your device. Similarly, you should be seeing the virtual environment being suggested. So when you choose this virtual environment,
But we're
the
not,
Jupyter,
so for Jupyter, because we're not using it right now, it's activated. So you can just say Streamlit run app.py. Because it's installed under Venv,
yeah,
you should be good. So just follow what Mehdi just showed you.
and
Create a
then
virtual environment,
Streamlit,
run.
yeah. So I already have a Streamlit installed, but it just says
What?
I can have a demo with this Streamlit hello. Streamlit hello. Okay,
Don't worry about the email.
yeah. It was just a demonstration for you guys. Okay, now I am going to stop sharing.
Okay. So Python, for people who did not follow, Python-m Venv, name of the virtual environment, right? And then here, Mehdi just did Venv, which works. This is not Python code. You run this in terminal, okay? In terminal, okay? Then you say source, then say the folder /bin/activate. That will create this parentheses before your terminal, which means you're using that Python. Then you run pip install -r requirements.txt, which is the requirements file I gave you inside, and that'll install the things we will need for today.
Prof, we're still seeing your browser. You need to switch your screen. Sorry.
Which am I not sharing?
You're just sharing your browser, so we didn't see anything, any command that you were entering.
How about this?
Yeah, now we see it.
Okay. If people are under Windows, source doesn't work in Windows, right? Or does it? Thumbs up, hearts, if you have things working now. How do one of you have a yes on with Starfish? How does the yes work? Okay, I'm scrolling down. Okay, everyone seems to have it now. Okay, and you see the thing? Okay. All right. So now we're one step closer to being able to create that. The idea in Streamlit is that you change something in the interface, it goes ahead and runs the whole code and then updates the visualization, okay? So now we're going to start by loading the data. Okay, so just like normal Python, you can import libraries. You're doing Python, right? So we're gonna do JSON, which is the Python library that allows you to read JSON files, and then you can import pandas. Okay, so we basically can create a load data function, which we can just give it a path. For now, we can give it a default and say business locations.GeoJSON. You can then change the path if you have to. So if your path is different, you give it a different path when you run the function. Okay? The way we open a file, we say with open the path as f. Here under with, we have access to f. It's a file. You can type GeoJSON equals JSON load s or load f. Rows equal, you create an array. These are the rows in your GeoJSON. And then you can say for feet in GeoJSON features. So let's just look at how this works, right? GeoJSON is a JSON file that has a type generally, and then under features, you have an array of features. And each array, it's a very structured type of JSON. Each array has a type, it has a geometry that tells you whether what that geometry is, and then it has properties, which is like basically the tabular data around it. This is what a GeoJSON is, right? So we want to loop over the features of that GeoJSON. So we read the properties. We say, we basically access that like this. Then we read the longitude and latitude. We say feet, geometry, and then coordinates. And then we append that to the rows. My brain switches. I've been coding in JavaScript recently, so I have to look at my references. So you can add props here like this, and then you can just add the keys for longitude. Say this is long and lat. And you've done this last week probably a little bit differently. It's okay. And then you want to return a data frame. PD data frame rows. If I have no typos, this should allow you to read a GeoJSON. A GeoJSON that's, so basically I need to clarify, this function can read GeoJSON files that have only points. Okay? If there's other types of features in that GeoJSON, you will not be able to read it. This will throw an error. So I'm going to say data frame equals load data. This is our function. I call it here. And then I say st data frame. I think data frame is like this. And then you just pass the data frame to it, or head 200. And now we say always rerun, and we should be able to see the table. So I'm going to go back to the code, let you think about what's been happening here. You all see the data frame? We're getting there. Anyone still has trouble? We're good. Okay. So now I want to just show you something, how you might be able to use. So you can see this has all sorts of UI elements. Okay. We can use them. Layout and like we have layout stuff. We can create columns. We can create containers. We can create dialogues. Essentially, they have function calls for everything that you might want to use to create a more interactive system. So let's just try this. I want to use, my idea is to create something like this. Okay. So this is like an expander. You click on it, you see something, right? We don't want to always see the data set, right? We can basically say with ST expander, this becomes a button text. Then you can just put something inside of that. Streamlit knows that by clicking, you show it, and then you can de-expand and expand. It'll handle that for you. So we can now try that. We already have our data loaded, right? So we don't need to load the data again. Also, although there is, I'm gonna remind me to show you how to cache data, because that's like some things you don't want to run multiple times. If the data is not going to change, you don't want to repeat it. So that's how you can have Streamlit be more performative. So you can just say, ask it to cache a function and data, and that will allow you to fix that. Okay. So for now, we don't care. What I want to do is gonna say with ST expander, right? Look at data, SC data frame. Very simple. Let's go back to Streamlit. Because we have it on load, you can have it like this. You can search. It's pretty nice. It's pretty nice to do things with it. Oh yeah, like totally. That's a really good point. You can do anything. This is Python, right? Let's see what happens. One thing is that you want to make sure you use the right function, right? So like I can guess just by what we are using is that it has this function needs a data frame, but let's assume that we want to just write something. I think you can just write df describe. I believe that should work. Oh, and it reads it at a table. Good. It's smart enough.
आपके पास 2 कंपास कार्ड है
Please mute yourself.
Okay.
Okay, that was yeah, it's someone every time. This reminds me of COVID times. The mistakes people make are now much less harmful. Just like how I streamed, just like the whole quiz response. Or now I was just streaming like another browser and talking for 5 minutes. Anyways, Atif, that was a really good question. So you essentially can write anything here. So actually we can try something, can show the table, and then you can like can give some, I don't know. You can use an F string. F string are things that you can use as templates, right? So under F strings, you can have these curly brackets, and you can just say, and locations. No, that should be outside of the curly brackets, right? And then you can just say, okay, how many neighborhoods it has as well. You can just do something, df, I believe neighborhood. And then it just, again, you've already learned a lot of pandas, right? So you can do all sorts of things here. You can just add stuff inside of your, we're good? We can see the data? Okay. Now, we're going to add a lot of interactivity, but let's try to add the map. We'll change it later, slowly. But let's try adding the map. So let's go back to code. Let me look at my cheat sheet. Import Plotly express as px. Let's just call it px. We're not going to do all sorts of matplotlib stuff. We taught that, but hey, you can use anything. This plotly express is a nice library that has a lot of, it creates just one figure at once, right? So let's say you want to create a 3D scatter plot. It's just one line. It's opinionated. It knows, it has some basic ideas. You can do stuff with it, right? So you can have maps that change. So today we're all about interactivity. So we wanna be able to read that, right? So we've imported Plotly, and we basically what we want to show in our chart is we're going to create a fig, and we want to say px dot scatter map. Okay, now let's go back to the functions, scatter map. Okay, we want to create something like this. Scatter map basically uses maps to create these interactive maps where you have some background maps, so it just gives you context. Okay, so what do we need? We need a geographic data frame, we need a latitude, we need a longitude, and then if we want, we give it zoom and other stuff. Okay, you can do all sorts of stuff with it. Can make, it's pretty complicated. You can make a cluster, you can add lines, you can do all sorts of stuff. Anyways, feel free to go and try it. Okay, but let's just make it simple. So we pass the data frame to it. We already have it. Say latitude equals lat. Longitude, you can guess, long. And you can just give it a zoom, give it a height, some height. And then we can say map style. I like, you can just say, I'm going to show you two map styles. If you go to the documentation, you can see the strings that it has. OpenStreetMap. So if you come to get an error, where? So no error now. Lat, long, zoom, height, map style. The error is ST right. I think the error is here. And then the scatter map is, yeah, I need to show it exactly. So the next thing is you can just say st plotly chart, and then fig, and then use, I think, container with, it passed that so that it just, oh, it's complaining. You want to say width equals stretch. Width equals stretch. Okay. I guess we have our basic map. Sounds good. I don't know why I'm seeing an error. There's something going on with my Python. You know what? To make sure that I know that things are running, I'm just going to say print running in the beginning. So every time it refreshes, I see running first. Yeah, this was working. No, let me just bring this back. Yeah, this was also fine. There was no error. I was just tripping. Okay, I'm going to show you the code. Add this. Just do this. And I promise that I'll show you the other base map that I like more. Let me find my cheat sheet. Yeah, there's like this one that's nicer, in my opinion. Carto dark matter. So it's like slick. Cool. So you have the data set. Yeah, pretty much. Discord dark mode. Carto dark matter. Yeah, it could be a Harry Potter name. How are we looking? We're seeing the map? Hit that like button if you are. Also, I have a complaint. I think none of you are watching the videos. There's 30 of you and there's 10 views on some of the videos. What are y'all doing? I can tell. The views need to be at least 30 for the class. Streamlit is lit, yes. Yeah, the map looks nice. For anyone who's taken my class, this is basically a dumber version of Leaflet. You can do all sorts of crazy stuff with Leaflet. And by my class, I meant visualization class. I don't think I'm teaching it next year for some reason. Okay. So while we're at it, I'm just looking at my notes to see what we have. Okay, so while we added, we can also add tabs here, just so you see what other layouts we can create. So st.tabs, you pass a list to it, and you can say map, you can say dimensionality reduction. These are the two things we want to do, okay? And then you can say map tab, comma, and then dr tab equals. We create two tabs, okay? Now, you can just say width, map, tab. You know the drill. Let's see if you can see this. Cool. Yeah, now this is under our tab system. You have another UI element. And just a hint for any of you who's trying to get some data science jobs, I show them if you want to go and say, oh, I can do data science stuff. Jupyter Notebook is good for nerds like us, but take your Streamlit apps, host it somewhere and take it to them, and then be like, hey, I can make these interactive systems and no problem. And then I know vibe coding is, you can just do this with vibe coding, no problem too. So you might as well do that as well, but we can do a lot of stuff. Once I made an app real quick that allowed me to search by similarity with an AI. I'm going to teach you some of that next, maybe tomorrow. Just search the text and find the documents that match my search using Streamlit. You can prototype data science ideas and apps really quickly. Okay, I stalled enough. You guys have your tab stuff? Obviously, you can just say right map. Okay, we have our map code, but what do we want to do? We want to be able to run. Let's just make a map where you can run k-means on it, okay? For now. That should be our goal. Then we start adding other things. So because we want our map to show our k-mean stuff, I think we should just do stuff between the data peak and the map visualization. So what? We're going to import that batteries, yeah. We're going to import scikit-learn cluster import k-means. Why is it thinking that am I mistyping import or something, or am I right? I don't know. I think it's fine. Okay. So yeah, just import k-means. So I'm sure you all have done this. So let's look at the data. Why is it thinking, oh, I'm typing JavaScript here. And it's probably not even JavaScript. I'm just not in a best coding mode. Okay. So let's look at our data. For your assignment, we've defined that you're going to do one hot encoding, dummy variables, and do clustering on everything and on lat long. Let's just do, today, we're just going to do clustering on these 4 columns. These are all numerical, so it makes it simple. But these are in different scales, right? Remember, we need to scale the data for distance-based things because things are if this number is higher, it's going to overpower the other thing. So you want to scale them. We've taught that, go back to the thing, but just a reminder. So there are different scalars that you can use. Here, we're just going to say from scikit-learn, pre-processing, import, standard. Since we just want to use the numerical columns, I'm just going to cheat stwrite df columns. Okay, I'm just going to go back to Streamlit. I just don't want it to. I'm just going to create a list and numeric calls equals. And I'm just going to add these, hard code these for now. You can later say, okay, I'm going to read and find anything that's numerical. Let's not do that today. Okay? Then I'm just going to say floor area. Do you think we can copy and paste? Like a true programmer? Yeah? So go back to Streamlit. You can do your copy and pasting any way you like. Daily foot traffic. Community. And annual revenue. Okay, so we have the list of columns that are numerical. What do we do? What do we do with these indeed? We want to scale these. So for now, we're just going to say calls, correct, to NumPy. That is our x. And then we're going to say x scaled equals standard scalar fit transform. Okay? This, again, this is the pattern you've seen 1,000 times. So it's pretty much, okay? And then we're just going to say stwrite x scaled. Let's see. Let's see if we've scaled it. Yeah, so it's everything should be scaled from 0 and it has symmetric based on standard deviation. You can do min-max scaling too. It's fine. This is the z-score one. So we have that. We have our x scaled. Oh, okay. And then we can basically say k equals, let's just say 4 for now. And then model equals k means, we've done this before, n clusters equals k. Let's just make k small. I think that's all we need, right? Am I right? We don't need anything else. Just need n clusters for k means. I believe so. So you're just gonna say labels equals model.fit predict x scale. SC right labels. What does this give you? The fit predicts first fits the model, then passes the X scale and gives you the clusters, right? This is the cluster labels of all your businesses in the same order that you're passing it. So we can do something nice with it. Am I going too fast? Are we here? Do we have the labels? We're good. So what can we do? We can add this to our data frame. So we can just say df cluster equals PD. Because this is numbers, but this is a categorical value. It's a label. You just say PD categorical, labels, and then you say as type string. So you cast your labels that are numbers because you want to treat them as categorical, and then you just say DST data frame df head. Let's just test. As you can see, I have a habit of testing things as I go forward. I have my cluster here. We're happy. Let's go back. We don't need this anymore. Our data frame now has a cluster column. So now that we have this cluster column, we can just add it here. Do you think it's complicated? You can just say color equals cluster. We have now clustered our points based on not location, based on 4 attributes, 4 features here. And then we created labels based on these clusters. We have them here. And then we use that to visualize our points spatially. Now, this is synthetic data, I believe. So clusters are nice. And there's probably this one yellow somewhere. So how can we make this interactive machine learning? The idea is very simple. You can replace this K with let's say a slider, ST. I believe that's the number of clusters. And then you gotta start from 2 to 10, I believe. We can just look at the documentation later. So, okay, and then we don't need the labels anymore, okay? Now we have interactive machine learning. Why? Because I changed this. The cluster is updated. We run k-means on the fly based on this hyperparameter. We show the results. Now, k-means is a fast algorithm. If you have a slow algorithm, it will be much more difficult. Okay, I'm going to show you the code just so you can see. It's really simple. Any variable that you want to pass as a hyperparameter, you can attach that variable to a function. This function is a slider, the output of which is assigned to this variable. Then you can use that as part of your clustering or any other. You can use it to create a linear regression or anything. You can use LLMs to do something. It just all works as long as it's Python. What else can we do for interactive machine learning? We can, instead of hard coding this, we can imagine you might have more features. and do st. Instead of having numericals, you can say st multiselect features to be used in models. Okay. Options. Now you pass numericals to the options and you can give it a default. Let's just say use all of that. So your default is still what we already did, but you can change that. You want to write this to something, so you can just say selected features. So selected features now is going to be an array. Let me just see st write if we have, okay? So you have an array, and as you can see, you can use a drop down, add to it. Okay? Boom, boom. So you know the drill now. Instead of using all of features to create X, we can just use selected features. Let's see. Doesn't it have defaults? So for some reason, the defaults wasn't working. However, we realized that there is a problem. Now we're using only these two features. We know that we need, I think, at least two features to use for different algorithms. So we can bake that in. We can say if length of selected features smaller than 2, st warning, pick at least 2 features to continue, and then you can just say st stop. What happens here, it will not run the rest of the code. So you pick 1, you pick 2. For some reason, the defaults isn't working. I don't know. Don't have enough time. So you can update your algorithm. So far, so good. So you have the drop down. What happened to the slider? Something fishy is going on. Yeah, we have to click out of it. So our cluster is good. Another UI thing that I've noted. So we can have number of clusters, right? How do we get the number of clusters? I think we can just say n clusters found equals df dot df cluster n unique. Let's just see st write n clusters. Yeah, so this tells us that we have found 3 clusters, 10 clusters, etc. Why this is interesting to show, because if you have a DBSCAN run, you can then replace this metrics. Okay, now instead of write, I believe there's like an interesting UI element. Is I believe metric. Got it. Number of clusters, and then you pass the value. So let's see. I think it just makes like a nice metric visualization. So if we have a DBSCAN, you can basically set it. Now, we're not going to have time to do the DBSCAN you guys have done it before, and I'll give you the code. But what we are going to do is to explain how that works. Now I'm going to even show you in my notes how we can select it. Because this is getting too cluttered, I want to take everything, all of these settings inside of a sidebar. I think you can just say sidebar, can create a sidebar and then just give it a header. Just say select features. Let's just move things to sidebars first. So you have now your sidebars. It's dead simple to take this to the sidebar. I think you just go sidebar.multiselect. I think that's all we need to change. Now we have our multi-select here, and it'll give you that problem thing so you can select your features. It's nice within the sidebar. You can make this not expanded. You can bring the slider here too. Let's do that. It's not a problem. Where's the slider? Where? I believe you can just go sidebar, a slider, same idea. Okay, I'm just going to create the UI element. And at the end of the class, we're going to give you just one task of adding DBSCAN to this. We're going to do dimensionality reduction here. You've done DBSCAN. Am I right, Mehdi? Last week, everyone's done DBSCAN, right? I think Mehdi is not hearing us. I think I've spoken with him and we can safely assume that we all have seen DBSCAN. I could ask you guys, but I don't trust you guys. Should I trust you guys? Do you all know how to use DBSCAN? Have you seen how to use it? You can go read on. So what do I want to do? I want to create another select that says st sidebar header to clustering, and then bring this k under here so we know. Actually, let's just put that here and then create a slider that says st sidebar select box. You can say algorithm, and you can just say k-means and DBSCAN. Obviously, you set that to algo or a variable. And then you say if algo equals k means, show this slider. This logic works in every, let's just bring that data here. So we have our data scaling here. This is our clustering. And then you can have another if algo equals k means models is this. So you do elif algo equals DBSCAN pass for now. Actually, I'm just going to do st right students at DBSCAN. Here, you're going to say DBSCAN parameters. Epsilon. Okay. Here is giving an error because it's under, I'm just going to say default k-means. Select box doesn't have a default. So let's go to Streamlit and go to input elements, select box. So label, options, index, format, key, help, unchanged, placeholder disabled, label visibility, width, bind, traces. So there's no default. The reason is that right now we don't have labels, okay? So we're having all sorts of issues, okay? So here I'm just gonna say catch error if no labels do not continue. Okay, when you create a DBSCAN, there will be labels. So I'm just gonna say just like the other one. If not labels, I think st warning, there is no clustering labels, and you can say st stop. I believe this is sufficient, and then we get rid of the default. For some reason, where is algo? There's no default. Okay. Hopefully, no, we still have issues. So I guess I have a typo. Labels. What if I say, I don't know, try it. My brain is tired, so model fit predict. Let's see. You know what the problem was? There was this if. I had a typo here. K-means was with M lowercase, here was uppercase. This, I believe, should solve. K is also not defined. We are going to do the same thing. K. Where do we do K? If algo, oh, here is the reason that truth value for any area with more than one element and because is any now we have that problem, right? So let's just say how to check if a variable exists. I don't remember. I am doing that. If labels not going to let me move forward. Model stage. Well, now this works. Okay. If we change it, it's gonna complain. But y'all gonna fix it. I don't remember how to fix this, but I just had an idea. I'll make the labels empty here. And then I'm just gonna say if length of labels less than equal 0. Okay. Problem solved for now. So to do for you guys is just here. Yeah, here add DBSCAN stuff. And this will always work. You always need a cluster. using this, and then you can write those clusters. Okay. So let's quickly run the dimensionality reduction and call it a day with BR tab. I'm just going to run PCA. I'm looking at the documentation. Okay, so we need to import the dimensionality reduction. So here we go from scikit-learn, decomposition, import PCA. Import PCA. We're good? Okay. So all we need to do, we can say reducer equals PCA. Remember what reducer does, right? It takes a list and a data set and gets the two most or n most important components that explain it. You can add a random state. And then simply, very simply, you say embedding. This idea of an embedding is basically foreshadowing tomorrow's class. Okay. Now embedding, we can just say st write embedding. Let's see. So it's giving us a two-dimensional data set. These are positions not on a geographic map, but on a scale that's basically X is PC. The first one is the first principal component. The second one is the second principal component. So very easily, we can just add these to our data set. Dimension 1 equals embedding 0, and df dimension 2 equals embedding 1. So we added these to our data set, and we can say big dr equals dx dot scatter. You pass the data frame to it, obviously. X equals dim 1, y equals dim 2, color equals cluster. I believe, and then we can give it a height equals to in pixels as well. Oh, no, nothing, not happy. Oh, and then we gotta show it. SD plotly r width equals stretch. Very nice. So these are clustered, visualized on a geographic map. These are our clusters visualized on PCA projection. And look, because we're clustering k-means on different ways, all of them get updated. Any questions? Do y'all like this? Is this a cool thing? Because I always enjoy quickly cooking up interfaces for data science stuff. I think you can use it in a really good way. You all have done DBSCAN on the same data set. All you need to do is to repeat the process for creating a DBSCAN here and add the UI elements you need for it. So an epsilon and essentially something like this. If it's DBSCAN, you show the epsilon. Oh, I refreshed it. Okay? How much time do you all need? Mehdi, you here?
Yeah, of course I'm here.
So just to add DBSCAN, 1 day is enough because they've seen exactly on the same data, you think? I don't know. Just 2
I
days.
think one. Actually, I think 1 day would be enough, but
I mean,
yeah,
they probably have more other things too. So let's make it 2 days.
2 days, okay.
I will give you the code we have so far. They will just add the DBSCAN and submit it.
Okay, so I'm gonna create the lab task 5 just right now. Lab task 5 plus string. Just add DBSCAN
To the Streamlit
to the Streamlit app.
Okay. Thank you for being here. We are, Mehdi and I have, I've decided on your final project. And by tomorrow night, we're going to give it to you. Just a hint, it's going to be in phases. So essentially, we're not going to have assignments anymore. You're going to have phases for your final projects because we're going to manage. I know I've seen how y'all do assignments, like after an extension, 11:59, you say, oh, can you give me like 5 more minutes? No, we're not going to do that. We're going to have 3 phases, and then you're going to present around August 10th or 15th. You'll see the details of the project. Any questions? We good? All right. Let's stop sharing.